I am Adriana Ponsanelli. I've been trying to go through a lot of sources. I think I have gone through like about 100 different sources to try to understand what's going on with this virus, why is it so infectious, and what can we do, like if we get infected, if we can do something about it. You know, we are like about 7 billion people in the planet, and there is so many there is just not so many hospitals for everybody. And since it's very contagious, I just wanted to see if I could find anything other than, you know, going to the hospital. If I know that someone is sick or is carrying the virus but they are not sick and they could infect others, things, easy things we can do at home. Now, nothing of what I'm going to share today is scientific because it's not been proven. Sometimes it would take like about 10 years to develop properly a drug and test it for, you know, for a virus. Now, we know that there is a vaccine coming, but of course, these vaccines have no time to be proven. We're doing this out of desperation. But you know, we know that there are a lot of natural substances that are not, you know, they don't have so many secondary effects as medicine might have, and that they could be available for a lot of people. And even though we don't know if this works, um, you know, by having some common sense, who knows, it might work. And I'm going to show you where I got my information. I want to go through a study, actually my favorite study, where I mostly got all the information to put all this together. And I want to show you, you know, how it works and what I thought about this. So this is the virus, the anatomy of the virus, and this would be called the spike. And the spike has two parts. It's part S1 and part S2. And this would be like part S1, and then this would be like part S2. I think it's 1 or 2, I don't remember which one is which, but this is the part that is the infectious part, right? So if this part is on its own, just floating on, you know, in the cell, or, you know, in the outside of the cell, it won't do anything. It needs to be attached to the virus for the virus to have all the instructions for the protein. So they are very antigenic, what means that they will cause the immune system to react. As well, the envelope is a very antigenic part of the virus. So when our body recognizes the virus, especially all the proteins that are made, the proteins that the parts of the virus are made, our immune system is going to fight back, right? So they're very antigenic. Now there is the other, these orange ones that I have. They are called hemagglutinin neuroamidases, and what they do is that they attach to the blood cells, and they attach to sialic acid receptors. This one would attach to ACE receptors, and also some sialic acid receptors, and many other receptors. But mainly, what makes them so infectious is that it attaches to our human cells ACE receptors. It's just like a phone. You know, I have a phone here that I can show you how it works. Like, imagine this is our cell, and this is this part of the virus, right? So what it's gonna do is that it's just the perfect match for our, let's say that this is our human cells, and this would be the ACE2 receptor. So it would just have the perfect match to it. And what makes it different than to other coronaviruses is that the, you know how, like, some magnets are stronger than others. So this magnet for this receptor, it would be like a very, very strong magnet, is different than previous coronaviruses. And what they have seen is that the proteins that make these spikes are very similar to a couple of the proteins are actually identical to the HIV virus. So that's why it is very infectious. It's very, it just like latches perfectly into our cells, especially the cells that have the ACE2 receptors, which are all the mucosas, like your oral mucosa, your esophagus, all your intestines, and also all your respiratory tract mucosas. So all the mucosas that have ACE2 receptors. And ACE2 is an angiotensin regulating receptor. And what it does, it's that it regulates your blood vessels, like it constricts them, or it regulates the kidneys, and it does many other things. And they do a lot of necessary things for the body, but in this case they also attach to the viruses. Okay, so now I'm not a virologist. I just want to say to you that I am not a virologist. I am a mom, and I studied dentistry. But I am fascinated with viruses, and I'm fascinated with microbes. We do a lot of microbiology in dentistry because it's the number 2 place in the body that has the most microbes, and it's the most exposed to the air. So that's why I love microbes. We do a lot of microbes in dentistry. Anyways, yeah. It's a lot, guys, but it's very exciting because I want to share this with you. We're going to go through a before I go and see more research, the research I have for you, I want to say we already went through this, so it has the virus when somebody sneezes, achoo, and then the virus is like moving like this three-dimensionally, floating in the air, and then it sticks to me, let's say like this, with spikes, right? Look, like the first spikes that it will it will attach to my clothes like Velcro, right? Or that's why they are asking us to stay home, because they do attach to your clothes, to all the surfaces, but especially like they would attach to the inside of my mucus. Like imagine that it goes inside my nose, and then it has so many ways to attach. Now the first the first things it will attach is into the spikes. We already talked about it, but then it has other different ways it attaches. And then, for example, let's say like these parts that I put, they're for like attaching to the cell, and then they have some enzymes that will dissolve the membrane of our cells. So it will secrete like an acid thing. Let's just think about an acid, and then it will literally dissolve the membranes, so the virus can enter, push the membrane of the cell and then enter the cell. Some of these viruses, their envelope will become part of our cells, and then it will totally uncoat itself, and now I have this one to show you. It's another toy of my son. So let's say like it already entered the cell, right? And it will encode itself, and then it will literally disintegrate the envelope of the virus, and this will become part of our membranes, or maybe just enter like this, but then it will encode itself. So the cell cannot recognize the virus anymore, right? Because it's this one's the envelope will be totally broken in pieces, and form part of our cells. And then the RNA, which is one, is like this, right? It's one single stranded RNA, will be copied by the ribosomes. So these are inside our cells. So we're already thinking that this is already inside our cells. So imagine that these are the ribosomes, and the ribosomes are literally copying machines. So what it does is that it usually copies our own RNA, but this time it will copy their RNA because the bases are the same. So it can copy any kind of RNA because it is the same RNA. The difference is the way in how the small little pieces are assembled. It has a different sequence of assembling. That's why it's the virus, right? So the sequence of assembling will totally fit into the ribosome. So the ribosome is not very aware that this is information not belonging to this human cell, but is belonging to the virus, and it will just copy the information. So it's gonna be copying like this, like if it was a machine, and then as it goes copying the RNA, like I have this so to show you, like it starts making these little things like proteins. Yeah, see, like it's gonna start making teeny little like pieces. So it's gonna stuff is gonna come out of here, and these are gonna be new proteins with the information of reading the RNA from the virus. So at the end, you will end up with a bunch of proteins, like a bunch of little proteins like this, right? And then they have to, then the virus will use our machinery that it's inside the cell. Like think about that it is like like a company that has many sections, and then the virus will use all the sections of the company to make their own product, their own clones. So and that's how it starts assembling itself in the sequence that it needs to be assembled to make their own RNA. So as you can see, from the time the virus is, in the air or in someone else's, in an animal, then from an animal to a human, and from a human to another human, and inside our lungs, it has a long pathway, right? Which it's very infectious. It can infect us really quickly, but because there is so many steps that the virus has to do to infect our cells, get inside the cell, and then reproduce its own information to make a lot of clones of the virus, then that means we have a lot of steps that we can actually interrupt for the replication of the virus. So that's the good news. And so we can start from like going back, right? And then stopping the virus from actually attaching to our surfaces, which is what we're doing right now. We're stopping contact with each other, so we don't transmit the virus from person to person. But now what do we do if we already are in contact with the virus? If we have someone around us who is sick, let's say someone in your family got sick, and then you have all other members in the family who are exposed to the virus. And so then we have to use other methods to stop a different pathway of the virus. And so we stop. So we can stop the virus, and I'm gonna bring again my toy here. We can stop the virus by stopping the S spikes, which is like the most important thing, from attaching to our cells. So stop it from attaching to my mucosas, right? That's one of the steps, and is the most important step. So what can I use to stop the spike from attaching to my mucosas? And that's how the vaccines, that's how all the antivirals are, going to be designed. And through stopping every process of the virus. So this would be like the medicine, the compound, and then let's say that this is my mucosa and this is the virus. So I drink the compound, and then so the virus cannot attach to my cells, right? So that would be one thing. So they are called ACE2 blockers. Right? Now there is another way we can block, because right, we can break the spikes. We can also break the spikes, right? We can disassemble the spikes and then like make similar molecules like this that will let's say similar molecules like this, but that they are not exactly this, but that they are like built in a way that won't work with our receptors, and then just have them. So the virus thinks that it has its spike, but the spike doesn't work. So that's another way. Then the other way is blocking the hemagglutinin receptors by blocking the sialic acid receptors in the human. So let's say again, so that will work in the human. Then let's say again, so sialic acid receptors. So now the receptor is gonna try to attach to my cell, and then so it doesn't work. So that's another way of blocking the virus. So we can block the virus in all these, attachments, right? And then we can, so now what do we do when the virus is inside the cell? Okay, let's say it was able to attach, it was able to get inside the cell, and now what happens? So now there's as I said, there is a long process that the virus needs to infect, right? It needs to copy its RNA in the right way, in the right sequence, to be able to reproduce virions. And for that, we can have the process. So in our cells, that's another thing. We have like little enzymes. Let's say our cell has these scissors, and they're enzymes. And what all enzymes do, there's a lot of enzymes. And enzymes, we couldn't really live without enzymes, because enzymes are actually the proteins that just do things. Like they cut things to be able to paste. It's like when you're trying to do a project, like if you don't have scissors or something to cut, how are you going to work? You have to cut all the things in your project, and then to be able to paste them in the right way, so your art is going to look the way you want it to look. So our cells have these like scissors, and these like scissors are called the furins. And the furins are, we have a lot of furins through, and they're used for a lot of things. Like, for example, for when the baby is inside the mom and is all the cells are, a lot of biochemistry is happening. There's a lot of furins because a lot of things have to be as well unassembled to be able to assemble in different ways to make all the tissues that we have. So it's a normal enzyme that we have, but some people have it dysregulated because there is a gene that regulates these enzymes. And if you have it, functioning more than what it should do, then it's not very good because it's going to be like, Edward Scissorhands, like chop, 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 and then like build, and then you're gonna create a lot of stuff. And sometimes the faster it goes, and it starts making mistakes, and sometimes it's a lot of the misfunctioning of furins is tied to some cancers and some like other really kind of ugly diseases. So furins have to be regulated to be able to, for our body, everything has to be regulated, to be able to work properly in our bodies. But so this is the other reason this virus is so infectious, and is because of the furins. Like, it can actually attach to the furins, and it can use them. It can use our own furins to be able to unassemble, like Edward Scissorhands, chop, 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 and then build its own RNA. Okay, so that's another way we can have. We can use compounds that block furins, so block the scissors that it's going to, work for, on the virus, and then we can just like block them. We can use different types of compounds that will block, the scissors that are going to be used for, the enzymes for the information of the virus. Yeah. Oh my god, it's a lot, guys. Hold on a second. Let me take a break. Okay. Now let's go to the interesting part. I'm gonna share my screen. Okay. Now we can see there. This is where I want to show you. Oops, sorry. Okay, there it is. Okay, this is the to me, like, the most impressive research. So it's done by the Chinese, and look at the date. So it's a recent research, February 27, and let's go through this quickly. So this is the way they did it. It says SARS-2 has caused tens of thousands of infections and more than 1,000 deaths. Well, now it's like way more. I haven't even tracked how many deaths are now, but it's a lot more than that. Now, what did they did? There are currently no registered therapies for treating coronavirus infections because of the time-consuming process of new drug developments. Drug repositioning might be the only solution to epidemic of sudden infection diseases. So what they say is like they are searching for different drugs, different compounds. This is the only way they can do it because we have such a short time to stop people from dying and from getting sick and from passing around the virus. So they analyze all the proteins encoded by the virus and they compare them with proteins from other coronaviruses and then predicted their structures and built 19 structures that could be done by homology modeling. So basically what they did is they studied the virus and they saw what are the proteins or the most important proteins that they could use for studying some compounds that would block these pathways I was talking about before. They use a library of database called Zinc, and then they use their own database of natural products. Okay, and this is all the most important proteins or parts of the virus that they came out with that they were the most important to arrest in the cycle. So we already talked about those. Okay, so now we're gonna go to the fun part. So there are some enzymes, and the most important enzymes that they thought that they could use and block, it's the 3CL-Pro and the PL-Pro. And these are enzymes that the virus use to transcribe their information, their RNA. Okay, so we're talking about how to stop the virus when it's already inside our cells. Okay, and that's what we're going to see now. Okay, so this is the compounds I found, right? These are potential PL-Pro inhibitors from Zinc. So Zinc is the name of the database that they have. It's not the zinc. They're not talking about zinc as a mineral. They're talking about zinc is the drug database. Now, these are all that they listed that can kind of stop this enzymatic process. So you can see here, you might be, if you're a doctor, you might be able to recognize some of these. But look, I pinpointed riboflavin. So when I release my video about juicing, you will see that I added, Moringa. And Moringa can give you 80% with one serving. It can give you 80% of the riboflavin that you would need on your daily basis. So by adding little things like this into your daily life, you might not be able to cure yourself, but definitely I believe it totally can help. And when you use a lot of compounds like that are already researched, that are already binding to some steps and halting some steps of the virus process, when you use them a lot in synergy in your foods and in your supplements, you can really, I think it will be even more powerful than any other therapies. Look what we have here. We have ascorbic acid. So as L-ascorbic acid, and that's vitamin C. And I have this supplement. And now I am currently not selling any supplements yet because this virus came just way before I finished setting up my store. But you can buy it in Amazon. I ordered it for myself, and I think it's a great supplement because it has the right type of ascorbic acid, which is L-ascorbic acid. And this is what they are showing here in the, because there is many types of vitamin C, right? Like this is what they're showing here in the study, L-ascorbic acid. And this one has 4,000 milligrams. So that's 6,700% of the daily value, which I think is the right dose. You know, 1 teaspoon of this is a powder, will give you 4,000 milligrams of L-ascorbate. And then you have calcium, and then you have magnesium as ascorbates, all of them. And then you have zinc as zinc ascorbate, and potassium as potassium ascorbate. So I think this is a great supplement. Yeah, you can take a screenshot and then order it in Amazon. Glutathione, and I don't have my glutathione here, but if you go to Quicksilver Scientific, you will be able to find their glutathione. I've used it. I actually bought boxes of it, and I use glutathione for a long time because my glutathione was really low. And this is one of the most important antioxidants, and you can see that it also blocks the virus. Now, asparagine. And asparagine, I had to actually go and research this. And asparagine is a compound in the peel of the citrus. So when you go and see my video, I added an orange peel to the recipe because it's found in the citrus peel and in the citrus, and they actually sell it as a supplement. And it's this. I bought it in bulk supplements. And the supplement is called asparagine, not asparagine. It's called asparagine. But asparagine, so this supplement, will convert to asparagine, the active compound, once it's in your body. So this is a great supplement, and I actually didn't only see it in this study, I saw it in other studies as well. And I saw it also, asparagine also stops the spikes, the S spikes, from binding to AC2 receptors. So it works in different ways and in different steps of the virus. I think that's one of the reasons that when they were giving vitamin C to patients that they were really ill, some of them were able to recover. Okay, so milk thistle. Milk thistle, silibin. So silibin is in the outside coat of the milk thistle. And milk thistle, you can buy it in a capsule. I don't have capsules, but I like it fresh. I order fresh seeds of milk thistle, and I put them in my coffee. I grind them and I put them in my coffee. Mimosa pudica, this is from a different, it's not in here, but this is from a different research, but that also works. Okay, so now you have, I started kind of like highlighting the ones that I saw the most, and I want to talk about skullcap, Scutellaria bicalensis. It blocks different, it has different compounds, first of all, that block the pathways of the virus. One is crescin, one is bicalene. Let's see if we see more down here. Here it is, crescin 7 OB glucuronide. And here, cosmocin, and that's it. But that's a very good one. That's a skullcap, and I think there is a new product called Reverse FX from Joy Phillips, and it has a skull cap in it. I think that was one of the things that he couldn't get a hold in China because everybody was using a skull cap. So it has many other antiviral compounds. So you can also, go into my viral dark matter group, study of phages and viruses, and directly contact Joey Phillips and ask him if he could, get a hold of you from his supplement. What else? Okay. The number one compound that I saw everywhere was the number one supplement, or like herb that I saw that was, in all the studies. It's Andrographis. So Andrographis is a plant. It has an amazing property to be an antiviral, and it's been used for many years, especially like is one of the most important plants in Asian countries. And it has many names in different countries, but basically is like anti-inflammatory, antiviral, antibacterial, and it's an adaptogenic herb. And look at how how many compounds it's in that plant. So look at how, like, everything that you see blue has been seen to attach to enzymes of the virus. Look, so Andrographis is everywhere. So I think that is like a, if I would have the virus, this is where I would get to first, Andrographis. Now all these, Andrographis is a very strong plant. It's a very, very strong antiviral. So I am not going to talk today about the number one most important thing, which is the diversity and amounts of our microbiome. You should already know that your microbiome is the number one most important thing to prevent you from any disease. So if you're doing antivirals, any antimicrobials, you should be replacing your good microbes, because these very strong plants would also sometimes not only attack the virus, but they will also kill your good flora. And if you don't have a good flora, you do not have an immune system. Okay? Your gut flora regulates your immune system. That's the number one thing. 80% of our immune system is under the mucosa of the under the layer of the mucosa of all mucosas. So 80% of the immune system is in the digestive system. And also the lung has its own microbiome. The lungs are not sterile. In fact, it's been proven that healthy lungs have also a microbiome, and it just makes sense because if you're living in a beautiful landscape, in a beautiful environment, you have the earth and the soil, right? You're not breathing just dirt, you're breathing soil. And so when you breathe soil is the mass of, it's like a whole ecosystem with bacteria and fungi and viruses and minerals, and it makes this rich, beautiful thing that makes our food to be able to thrive. So when you're breathing good soil, you're inoculating your respiratory system with beautiful microbes. If you're living in a city that is polluted, you're not breathing good dirt microbes anymore. You're breathing, toxic substances that are being released into the air. So your lung microbiome might not be as healthy as the lung microbiome of somebody who is living in a beautiful, healthy rural area. Okay, so what else? I have a lot of stuff, and this video is gonna be very long, but I hope that you at least get be patient to listen to me, because I am not a fantastic speaker, but I just wanted to share all this information with you, and so just not let it only for myself, but just like to help as many people as I can. And even though this is not proven, then you get all the information and you can make your own decisions. Okay. So let's pick another one, because there are so many. You can go through this on your own. I wanted to do this one. This one is a common herb in Ayurveda, and it's also common in China. So in China, it's called Nagarmotha, and it's called Musta in Ayurveda. So this one is also an anti-HBV, and you can use it for this virus as well. You can search for it as Musta. I've searched already in Amazon; they have it. Viola diffusa. Viola diffusa are violets. So actually I did a lot of research in this one, but I couldn't find the specific violet. It's a flower, right? Couldn't find the specific strain of violet that it's seen in this study. But I thought there were many other violets. I thought, it wouldn't be something harmful to make a beautiful salad. And if you have available some violets, just use them. They are edible flowers, and they're really healing. The beginning of, anyways, you can go through it on your own. Now I'm going to share my other screen, and this one is a video that I am promising. I'm promising to release this video. I'm currently working on it, but it's about a juice, and so you can juice for health, and a lot of other compounds. The foods that I put in my juice are backed up by this science. And so I put coconut oil, and this one is a different research. It blocks furin. It's a furin blocker, and this one was added. I had to ask Joey Phillips for this refer for this studies. So he actually proved to me that coconut is a furin blocker. Then I added Moringa, which is a folate receptor, has folate, and is a blocker of the receptor of the ACE2, and is an oxygen producer. Has a lot of chlorophyll, which it also is similar to our own hemoglobin. So I added orange and orange peel, which has a spiritine that converts into spiridine, and it's also a receptor blocker. The lemon juice that has the vitamin C and all the other compounds. Ginger, which is a non-antiviral, not specific for this virus, but you can use it. Turmeric is an anti-inflammatory, an immune modulator, and antiviral. Cucumber. We need to keep our mucosas really moist, so make the virus, make our mucosas slippery and really hydrated, so the virus doesn't attach as as well to our cells. So more viruses kind of like, you know, slip off the mucosas. And then Vitis vinifera, and this is something I'm actually been taking. Vitis vinifera, and I ordered it in Amazon. It took a little while to get here, but it's sweet and it comes in a dropper. You can get it as in many ways, but it's very sweet. It's like the grape. Put in a bottle. It's super sweet and it's delicious, and it's proven to block the ACE2 receptors. And then there is fennel, and fennel has many, you know, great properties. Is great for the kidneys, and one of the problems with this virus is that it was affecting the kidneys of people, because kidneys have a lot of the ACE2 receptors, kidney cells. What else? Folates. Folates are so important. If you have an MTHFR mutation or any kind of mutation related to folic acid, then you should be taking folate. And I have this brand that I buy. I also, you know, I am hoping to sell all these things in my store because I want people to have them available. This is a great vitamin, and I take it every day because I have the MTHFR double mutation. I already show you the Andrographis. Yeah. And then I have something that is not, it was not in the studies, but that I use, you know, for my heart, is Strophanthus. And Strophanthus, what it does is that it just relaxes you. And then if you have more circulation of blood, you know, that's why a lot of people that had problems with their heart and with their circulatory problems, also, you know, it was a problem with this virus because all the oxygen you know, has to pass through the lungs and then to the circulatory system to be able to oxygenate all the cells. So if your respiratory system is not working properly, then, you know, you're in trouble. So anyway, I think it was a lot. I hope that I didn't do a lot of I think I did, but I had to give you this information, and you know, hopefully you are you can go speed up through this video and get the information yourself. You can download the study and then go through all the stuff on your own. Anyways, keep safe.